Hi guys, so in this video I'm going to share with you how you can build your own Radial menu in Unity that works with any VR SDK, even for non-VR project. And you will see the result is going to be awesome. We will be able to tweak the number of options the user can choose, even add more space between the part, and trigger anything when the player selects one of the options. So get comfy on your chair and let's get started. As you already know, the source code is available on my Patreon, but wait, because I need your help. Developer Nation is finally putting a survey for XR developer. The goal of this survey is to collect information about what matters for us, to then give us a better understanding at how we can build things, which I think is awesome. And this is why I've decided to partner with them and share the result in a future video. I am very lucky to have a lot of developers on this channel that comes from different backgrounds, country and skill set, so this is why your opinion matters. So please take 8 minutes of your time and go to the description below to fill the survey. There are even prizes you can get from answering, so no excuse. But without further ado, let's get started. Okay, so here we are in Unity, and as you can see, I have a very simple VR setup right there with just a camera rig. So let's get started on the Radial selection. For this, I'm going to right click, go to UI, and then go on Canvas, which is over there. But the canvas right now is set to screen space overlay, which means that it will not be part of the world with us. So let's set it to world space instead. For the position, let's set it to 0, 0. The wides, I only want a wide of 200 on both the width and height. And here for the scale, let's set it to 0.001 on all axes. Beautiful. And already, as you can see, if we double click on it, we can see the canvas, which is taking shape like this. And the size seems to be nice like this compared to the ends that we have. So let's keep it this way. Okay, now that we have a canvas, it is time to create the little radial part that we will display. So my goal here is to say, okay, I want to divide a circle into different parts. How can we display these parts? So let me show you. We can right click on the canvas, go to UI, and then go to image. Beautiful. So for the image, as you can see, I have a reticle circle, which you will be able to download in the description below. So it's basically just a circle sprite. Now, after importing it to your project, don't forget to assign here the texture type to sprite 2D and UI and to click on apply, so that we will be able to go to image and simply drag it as the source image on the image. Okay, so now as you can see, it is appearing, but I want the image to take the full shape of the canvas. So let's click on here, press on the Alt key, and this should show the icon over there, and we can click on it, and this will fit the rectangle transform over there to the size of the canvas. Okay, now we have canvas and an image that looks like this, but the magic happens right now, because if for the image type we set it from simple to filled, as you can see with the fill amount, we can actually choose how many angles we want to display. And this is basically the whole thing that we will use to create different radial parts. So here for the fill origin, set it from bottom to top. This will be a bit easier. And let's say that we have 3 radial parts. This means that if we have 3 radial parts, each part will take 120 degrees because, well, the sums needs to be 360. So in my case, I'm going to duplicate the image 3 times. We can select all of the image and we can set the fill amount to 1 divided by 3. Beautiful. This will be 0.333. And what I'm actually going to do is set it to 0.3, just a smaller value than the third of the circle. And now with this, we have created 3 parts which takes under 120 degrees. So the first one, we can set the rotation to 0. The second one, we can set the rotation to 120. And the third one, we can set the rotation to 120 plus 120, so 240. Oh, let me put the canvas a bit above like this. This will create 3 beautiful radial parts with the correct angle. So to sum up, if you have X amount of radial part, you first need to go to the fill amount and set the fill amount to 1 divided by the number of parts that you have. And then you simply need to rotate each part by 360 divided by the number of parts that you have. Okay, so now that you get that, our goal is to do this, but in a script. So for this, let's simply remove the two images over there. This one, I'm going to call it radial part, and I'm going to drag it as a prefab in our project folder to save it and to be able to instantiate it after that. We can then select the radial part, press on delete, go to the canvas. I'm going to name it radial selection canvas. And actually, I don't want to set the radial selection script on this radial selection canvas. So instead, I'm going to right click, create empty parent, and this will create an empty parent, as the name suggests, that we can call radial selection. And we can, on this game object, add as a component a radial selection component. Okay, let's double click on this script to open it. So what we need for this script is, as mentioned before, we need a public int, which will be the number of radial part that we want to show. Beautiful. We also want a public reference as a game object to the radial part prefab that we made. And now little tips for you. So if we go back to Unity, the number of radial parts is just an int here that we can set over there. But here, little tips, we can improve the way it appears on the inspector by simply writing range 2 to 10. And there we go. If we save and go back to Unity, as you can see now, the number of radial part appears as a slider, which is way better. Okay, now that we have the number of radial part and the radial part prefab, let's create a new function down below, which we can call spawn radial part. Beautiful. Now on the script, we can loop for that goes from 0 to the number of radial part that we have. And we can compute the angle that I mentioned previously by doing float angle equals I multiply by 360 divided by the number of radial part. Beautiful. Now that it is down, we can then get a certain rotation based on this angle using a radial part Euler angle, which we can set to new vector 3 0 0 angle. Beautiful. This will rotate on the z-axis our object with the angle that we've computed over there. And now we can spawn the radial part with game object spawn radial part equals instantiate radial part prefab. And here what I want to do is set the radial part prefab as a child of the canvas. So we need to go at the top and write public transform radial part canvas. We can then set the radial part canvas as a second parameters on the instantiate function. Okay, now that we spawned a radial part, it is time to set its position and rotation, which we can do with spawn radial part dot transform dot position equals radial part canvas dot position. Now for the rotation, let's do spawn radial part dot transform dot local Euler angle, and we can set the local Euler angles to be the radial part Euler angle that we've computed just above. And beautiful, this will set the position and rotation of the radial part that we spawn. But of course, now the next step is to set also the fill amount on the image, which we can do with spawn radial part dot get component image. And as you can see, it doesn't recognize the image here, which you can fix by simply going at the top and writing using Unity engine.ui. Beautiful. Now let's go down below and let's do dot fill amount equals 1 divided by the number of radial part. But there is a problem right there because this computation here will always return 0. Why? Because these two are integer number, so it will try to return an int during the division. So what we need to do is actually write float in front, and this will fix our little issue. Okay, now let's save this script and go back to Unity to find out if this works. Okay, for the radial part prefab, we can drag our radial part that we have over there. For the radial part canvas, the radial selection canvas that we have. And for the number of radial part, we can set it to maybe 5. Now, let me just click on play to find out if the spawning of the radial part works. And there we go, we have a complete circle, which means that it works. Now, it is a bit hard to say it like this, but if we select all of the radial part and that we maybe reduce the filament a little bit, you can see that it has correctly spawned 5 radial part, that it has correctly set the fill amount to the correct value, and that it has also rotated the radial part to the amount that we want, which is super cool. But let's improve this script in 2 ways. The first one is that I want to be able to spawn and despawn the radial part on command, which is not possible because right now we are never destroying all of the radial part if we are spawning again. And then I want also to introduce here this little fill amount offset that we are doing by hand over there. So let's leave play mode and go back to our script to do these 2 things. Okay, so for the angle between each part, we can add at the top public float angle between part, and we can set it to maybe 10. And what we can do is simply set the fill amount and reduce the fill amount value by angle between part divided by 360, which will give us the correct ratio. And let me put some parentheses over there to make sure that everything is computed with the correct order. Now we can save, go back to Unity. The angle between part is set to 10, and if we click on play, there you go, it seems to have correctly applied the angle between part, but by adding an angle part, as you can see, it seems a bit weird because here I want this angle, so this part to be centered in the middle, which is not the case right there, but we can actually fix this if we go back to our script, and here I'm simply going to do plus angle between part divided by 2. And this should offset all of our angle to the correct amount to have everything positioned correctly. So let's find out if we click on play. Oh, it's actually on the other side. It's actually not a plus, but a minus that we need to write over there. And there you go. As you can see, it is much better. Now, it seems that the space between these two parts is centered at the middle. So this looks really, really better. And now everything seems super cool. Now, next thing that we want to do is be able to spawn and despawn the object quite easily. So to do this, I'm going to add at the top a private list of game object, which we can call spawn parts with an S, and that we can initialize with new list of game object. Beautiful. So at the start, when we are spawning the Radial part, what we can do is actually loop through this list. So the spawn part, and what we can do is actually destroy the element of this list, so by doing destroy item, and then do spawn parts.clear. So this will make sure that before spawning the Radial part, we are actually clearing the list. And what we can do is, once we are spawning a new Radial part, we can add to the list this spawn Radial part. So this will make sure that we are actually remembering each part that we are spawning, and that we are actually destroying them before spawning a new one. And we can already test this super easily by, instead of spawning the Radial part in the start function, we can spawn it now in the update to see if we can spawn or despawn the Radial part super easily. Now let's save and go back to Unity. There we go. Now let's click on play. So as you can see, our Radial selection is spawning the Radial part in the update function, so every frame of the game, which means that now, as you can see, we can update at runtime the number of Radial part, which is awesome. So this really shows how flexible our system is. It's so satisfying. Okay guys, we have succeeded to spawn the Radial part, but of course, we need now to be able to select one of the Radial part, which is the tricky things to do right there. But don't worry, because there are some math that will save us. So let me just give you some explanation here. So how can we select a certain Radial part? So let's say that this is our end, and of course, we need to find out which Radial part is highlighted from this position. And what I'm going to do is actually compute the vector that goes from the center of the Radial part selection to our end position. And what we can do is actually project this vector to this direction, so to the direction of the plane where our Radial selection is sitting. And this will actually give us a new vector that is sitting on the Radial selection. But this vector is very important because now with this vector, we will be able to compute here the angle of this vector to know where it is sitting. So for example, let's say now that our hand position is over there, we will be able to project this position here, and this will give us a new vector right there. And this vector with the angle that will be computed will give us the selection, which is this little part over there. So this is the thinking right there. So now let's try to do this in the code. Okay, so let's see how this works in our script. So let's go back to the Radial selection script. And what I'm going to do is create a public void get selected Radial part function. Okay, so first thing first, we need to get a vector that goes from the center of the Radial selection to our hand. So for this, I'm going to add a new public transform called hand transform. Beautiful. And what we can do is do vector3 center to end and do hand transform dot position minus Radial part canvas dot position. So if you don't know this, if you have 2 points A and B, you can get the vector that goes from A to B by simply doing B minus A. And this is what I'm doing here. I want the vector that goes from the Radial part to our hand. Yes, this is supposed to be a hand. So I'm doing a hand position minus the Radial part position. Okay, now that we have this, what we want is to project this vector, which we can do with center to end projected equals vector3 project on plane. And here we are projecting the center to end vector. And for the plane, we want actually to project on the plane that is defined by the radial selection canvas normal. So let's do radial canvas dot forward. There you go. And now we can simply get the angle with float angle equals vector3 dot sine angle radial part canvas dot up center to end projected, and finally radial part canvas dot forward. So why am I putting a sine angle here and not a vector3 angle? So now that we get an angle, what we can get is the current selected radial part, which we can add at the top with private int current selected radial part equals -1, and we can do current selected radial part equals angle multiplied by number of radial part divided by 360. This will convert our angles to a certain int value. And right there we have an error because the current selected radial part is an int and this thing is a float. So let's simply write int in front to do the conversion for us. And beautiful, now that we have the current selected radial part, what we can do is simply loop through all of our spawn radial parts with here spawn part.count. And if I is equals to the current selected radial part, we can do spawn part i.getComponent image, and we can maybe set the color of the image to yellow. Okay, so while we are at it, we can even also increase the size by doing spawn parts i.transform.local scale equals 1.1 multiplied by vector3.1. And if I is not equals to the current selected radial part, which means that we are not selecting this particular part, what we can do is reset the color to white and set the size to 1. And there you go, everything is done. Our get selected radial part should work like this, so let's call it after the spawn radial part right there. Let's save and go back to Unity. Okay, so what's missing here is the end transform. So just for the sake of testing, I'm going to right click, create an empty game object. We can call it maybe hand transform test. And I'm going to set its icon to this to be able to locate it a bit better. There you go. This will be just to test the position of our hand to find out if the selection works. And we can now drag it in the end transform and we can click on play. Okay, so let's move our end transform test. And as you can see, this seems to work in some cases, but in some cases not. So it seems to work only for the first one, but after that, it doesn't correspond to the value. So let's find out how this is not working. We can leave play mode and go back to our script. And here I'm simply going to write debug.log angle and do plus angle. This will display the angle in the console window. There you go, let's click on play again. Okay, so here is our console window. Let's take our end transform and put it above. As you can see, the value is at -1, and then it gets to -30, -40, -180, and then it resets, as you can see, to 180. So this is a bit wrong. There are two things not working here. The direction is not working, as you can see, because it should be a positive value on this side. But also after 180, as you can see, the value is resetted and doesn't get above 180. So let's fix these two things. So to put the value to the correct size, we can simply write a minus here in the sine angle. This means that the direction in which we are checking the angle will be on the opposite direction. And now to fix that the angle is not going above 180, let's do if angle is less than 0. Then what we want to do is do angle plus equals 360. There you go. Now let's save, go back to Unity, and let's click on play. Okay, here you go. As you can see, the angle seems to work. It's at 0 right there. It increased to the correct direction. And then after 180, it gets to something above to 360. So this is what we want. But for some reason, the highlighted goes into the other direction, as you can see. So that's another bug that we will need to fix. And the answer is that actually, as you can see, if I press on the pause button and that I select one of the radial parts, as you can see, the radial part that we are always spawning spawn into the left direction and not the right direction, which we are using for our angle. So as you can see, we are actually always increasing here the Z value, so the angle Z value. So this is actually rotating our radial part in this direction, which means that the radial part 0 is this one, this radial part 1 is this one, 2, 3, and 4. So this is not the correct direction because we want it to be on the other way, but we can fix this quite easily by simply leaving play mode, go back to Unity, and here down below for the angle value, let's simply put a minus over there. So don't forget to do this, it is really sneaky, but this will make sure that the rotation goes into the good direction that we want, so the one that we are using to compute the angle. So now let's save, go back to Unity and find out if this works. Okay, here you go. And as you can see, the magic finally happens. This seems to work perfectly. As you can see now, with the end transform, we can select a certain radial part and everything seems to work with all of the angle. This is magic. Okay, so we've done the spawning of the radial part. We've done the checking of the selected radial part, but now it is time to first be able to trigger an event based on the selected radial part element, and then to be able to spawn and despawn this radial selection with the press of a button. So let's see how we can do this. Okay, so back to the radial selection. To simply trigger an event from the selection, this is very simple. We can go at the top, and here I'm going to write using, let me zoom a little bit, and I'm going to write Unity engine.events. This will allow us to add a public Unity event of type int. So this means that the Unity event will take a int as a parameter, and we can add a onPart selected event right there, which we will be able to call. And so what we can do is create a new function called public void hide and trigger selected. And what we can do is call the onPart selected dot invoke with the current selected radial part onPart selected, and then what we can do is simply hide the radial part canvas by doing GameObject.setActive false. Beautiful. Okay, so now we have three functions. We have the spawn radial part to spawn the radial part, the get selected radial part to get the selected radial part, and the hide and trigger selected to hide the radial part selection and trigger the event that is selected. So now our goal is to trigger these two functions based on the input, and this is when you can actually use this radial selection with any SDK that you want. So here this part of this tutorial will work for the Meta SDK, which is the one that I'm using right now, but you can simply do the same thing for the Unity XR, for any SDK, even for a non-VR project or even for hand tracking. But let me just show you a quick example. I'm simply going to remove here the two functions from the update, and I'm going to go at the top and add a public OVR input dot button, which I will call spawn button. And this button will be responsible to spawn the radial part and to trigger its event. So we can do if OVR input dot get down spawn button. So if we are pressing on the spawn button this frame, what we want is to spawn the radial part. Now, if the OVR input button is down currently, so if during this frame the button is pressed or not, what we want is get the selected radial part. But if the button is up, so get up, in this case, what we want is to hide and trigger the selected. Oh, and by the way, before this, what we want is actually, when we spawn the radial part, something important is, of course, to spawn the radial part near the hand position. So this can be done super easily with radial canvas dot position equals hand transform dot position, and then radial part canvas dot rotation equals hand transform dot rotation. And let's make sure also that the radial part canvas game object is active before this. Beautiful. But now with all of this, I guess that you see now the big picture. When we are pressing the first time the button, we spawn the radial part. Then during this press, we are getting the selected radial part. And after we are releasing the button, we trigger the event with the current selected and we hide the radial part. And this is where you can actually change the input to what you want. You can basically call one of these three functions when the user is pinching with the hand tracking or do anything. It is really up to you. But now let's save and go back to Unity. So there we go. So now for the spawn button, let's set it to 1. Which is the A button on the right controllers. And let me demonstrate a quick example on how we can use this onPartSelected event. For this, I'm going to right click, go to 3D object, cube. This will create a cube which we can scale down and put in front of the user. And on this cube, I'm going to add a script called setColorFromList. There you go. And what we can do is actually have a public list of color called colors and add a public void function setColor, which will take a int into parameters and which will do getComponent renderer.material.color equals colors I. There you go. Very easy, as you can see. Let's save, go back to Unity. And now we can create a certain color list. Let's create maybe 10 things. First one is red, yellow, white, green. Okay, there we go. We have 10 colors right there sitting on the list. And now we can simply go to the Radial selection, and on onPartSelected, we can click on the plus button and drag our cube right there. And we can go to set color from list and select the set color over there, the one on top, not the one below, because this one will use the int value that we are setting from the Radial selection. Now, before clicking on play, for the end transform, make sure to set it properly to the correct end transform and not the one that we've used to test. So in my case, I'm going to go down my VR rig and drag the right end and show over there. Beautiful. We can even select the old end transform test and delete it. Now the moment of truth, let's click on play. Okay, and here you go. As you can see, if I press on the A button, the beautiful Radial selection that we made appears with all of the settings that we've created. We can change the number of radial power, we can change the angle between each of them. And if we release the A button on one of the elements, this correctly changed the color. So this is super nice. And there you go guys, this was a long video, but it was so cool to build the whole things from scratch with the power of mathematics. As always, a big shout out to my Patreon, you guys are the best, and if like them you want to get access to the source code and exclusive content, join us, the link is in the description. Also, don't forget to answer the AR/VR survey, which you can find in the description down below. This is very important as I believe this will give us a lot of information on how we as XR developer can better create our things. Thank you for watching and see you soon.